All right, for lesson 6.4, let's talk about inequalities in triangles. And remember, leading up to this, we've talked about inequalities in general. We've talked a little bit about indirect proofs, and that's kind of leading us into this new topic, inequalities in triangles. Let's take a look at the first theorem that we have for this section. It's theorem 6.2. It says if one side of a triangle is longer than a second side. So in other words, we've got this triangle, and let's say that down in the diagram, let's say that A is longer than side
Harley
B.
Eckstein to the office. Harley to the office.
All right, so if we have one side of a triangle is longer than a second side, then the angle opposite the longer side is larger than the angle opposite the shorter side. And really, if you reason through this, this would make sense. The problem is just really understanding it to start with. So, let's take a look at the triangle down below. As I mentioned before, we're saying that side A is the larger one. So A is the longer side, and B is the shorter side. Well, what this theorem is saying then is if A is the longer side, then the angle opposite that longer side has to be the bigger angle. And that should kind of make sense because if I, this angle right here, angle 1, has to open up more than angle 2 would in order to create this longer side. So, if you can summarize this theorem in just saying that the larger angle is opposite the longer side. And vice versa, the smaller angle, which would be 2, is opposite the shorter side, which is side B. Read it over a few times and we'll go through an example of that. Now an example of theorem 6.2 is this. Now let's take a look at the figure.
Harley Eckstein, please report to the office. Harley, please report to the office.
So let's take a look at an example of theorem 6.2. It says, name the largest angle and the smallest angle of the triangle. Now let's identify our sides here, which are longer and which are shorter. Now the largest angle, well, first of all, the largest angle has to be opposite the longest side. Well, what's the longest side? The longest side is this side that has a length of 10. So the largest angle has to be angle I. Right? Now, I could also put these angles in order from largest to smallest. Now, what's the smallest angle? Well, the smallest angle is opposite the shorter side. What's the shortest side? Right here, right? So what angle is opposite that side? Well, it's angle J. So angle J is the smallest angle, and then angle H would be in between them. So using theorem 6.2, I've been able to put these angles in order from largest to smallest. All right? And they just wanted us to name the largest angle and the smallest angle. But we went a little bit beyond that. All right, theorem 6.3. I've got a diagram. And really, 6.3 is, you could say maybe the converse of theorem 6.2. If one angle, only because we're switching the sides and the angles around. If one angle of a triangle is larger than a second angle, then the side opposite the larger angle is the longer side opposite the smaller one. And they've used a lot of words to say this. Really what they're saying is the longer side is opposite the what? The longer side is opposite the bigger angle. So with the information that I have here, and this is something that also that's a little tricky. Right now with the information that we have shown, this side is going to be longer than this side, right? Because the blue side is opposite the bigger angle. The red side is opposite the smaller angle. Now something that we need to consider here is what's that other angle? So in other words, if I add 45 and 22, that's 67, and take that away from 180, which is the total degrees of a triangle, we get 113, right? So this angle up here is 113 degrees. So technically, if they were asking with this diagram, what's the longer side, it'd actually be side AC. right? Because it's opposite the bigger angle. Now, that's not what they were asking, and this is just kind of a follow-up for theorem 6.3, all right? So let's take a look at an example of theorem 6.3. It says name the longest side and name the shortest side. Now I got to find that third angle, okay, in order to determine this. So I have 105, I have a 46. I'm going to add these together, and I get 151. Now take 151 away from 180, and I get 29 degrees. So this angle up here is 29 degrees. So what is the longest side? The longest side is opposite the bigger angle. So the longest side is that one. It's RT. The shortest side is opposite the smaller angle, which we needed to determine in order for us to figure that out. So it's RS. So the longest side is RT, the shortest side is RS. Now, before we finish up here, I want to go back to the example that I used back here to make sure that we did all the information we did, right? All the sides were labeled, unlike this one where we had to find that third angle. All right, let's take a look at corollary 1. Now a follow-up to theorem 6.3. Okay, it says the perpendicular segment from a point to a line is the shortest distance or shortest segment from the point to the line. And that should kind of make sense here. So in other words, if I wanted to determine the shortest distance between point A and line K there, it's not going to be that. It's going to be the perpendicular distance. So that straight up and down distance is going to be the shortest distance from that point to that line. Corollary 2, same thing with a point and a plane. The shortest distance from the point to the plane isn't something like this that's diagonal. It's going to go straight down, and that's the shortest distance from the point to the plane, which is the perpendicular distance to it. All right, last theorem that we have is probably the main one out of this, and it's called the triangle inequality. Right, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Again, to me, kind of a common sense type of theorem. So all this is saying is any two sides you add together, AB plus BC, that total, that sum has to be greater than the third side. And that should make sense. And in order for us to have a triangle, I should be able to take any combination of two sides, and it should be greater than the third side. So AB plus AC, that sum has to be greater than the third side BC. And AC plus BC, that sum has to be greater than the third side AB. In order for us to have a triangle, this has to be true. The triangle inequality theorem has to be true. Now let's take a look at an example of that. I'm going to go to examples of theorem 6.4. Is it possible for a triangle to have sides where the lengths is indicated? Well, let's take a look at A. So I got to test it. Any two sides I add together have to be greater than the third side. Let's see, is 14 greater than 10? It is. Now do another combination. Is 8 plus 10 greater than the other side? 6. It is. And now do 10 plus 6. Is that combination greater than the third side? Is 16 greater than 8? That's right. So this would be a triangle. Now, I'm not going to go through each and every one of these here just because it's going to take a little time here. But I want to go through one where it's not going to be a triangle. For example, down in E, let's take a look at this one. 6 plus 6 is greater than 10, right? So I use the first two. Now, how about if I use 6 and 5? Is 6 plus 5 greater than the third side? 6, it is. Okay, how about, so I've used the 6 and a 6, I use 6 and a 5. Another one would be using the other 6. So it looks like this is going to be a triangle, right? So this is a triangle because the sum of every two sides is greater than the third side. I'm just trying to glance at some of these others. How about D? Let's see, 4 plus 6 is greater than 2, so that works. How about the 6 and the 2? Is 6 plus 2 greater than the 4? That works, right? How How about the 4 plus 2? And here we go, 4 plus 2. When I add these sides, is it greater than the third side of 6? Is 6 greater than 6? No, it's not. So this is an example of, I could not have a triangle with lengths of 4 feet, 6 feet, and 2 feet. The sides aren't going to meet. So what this means is, if the sum of two sides isn't always greater than the third side in all the combinations, you're going to have a triangle where the sides don't meet. All right, so I want to finish up with this. It says the lengths of two sides of a triangle are 8 and 13. So two of the sides are 8 and 13. Now what would the length of the third side have to lie in between? Well, if you use the triangle inequality theorem or simply a shortcut like this, to find out what the length of the third side has to be greater than, well, let's subtract these two numbers. 13 minus 8, what is that? 5. So the length of the third side has to be greater than 5, and then add these two numbers together. 13 and 8 is 21. So the length of the third side has to be bigger than 5 and less than 21 in order for this triangle inequality theorem to work out. So this was just a little shortcut to kind of follow up to problems like these.